You are driving down the highway, cruising at a steady 65 miles per hour, and suddenly you feel this annoying, subtle twitch in the accelerator pedal. Or maybe you are sitting at a red light on a freezing morning and your engine starts shivering like it is about to stall out. Most drivers panic, assume their transmission is slipping, or prepare to drop $1,000 on new fuel injectors. But what if I told you that a tiny sensor, roughly the size of a matchbox, could be robbing your engine of nearly a quarter of its power and burning through your gas money faster than you can say miles per gallon? Welcome back to the garage. Today, we are tearing into the invisible air and fuel management network under your hood, breaking down why your engine control unit gets fooled into running rich or lean, and how a $10 can of spray can save you hundreds of dollars in unnecessary diagnostics. Before we get our hands dirty and talk about how your car measures the atmosphere, hit that subscribe button so you never miss these deep dive garage sessions. Let us kick things off with the absolute classic, the manifold absolute pressure sensor, or MAP sensor. If you drive a vehicle that utilizes a speed density system instead of a direct mass airflow setup, this little guy is the master mathematician of your engine bay. Instead of measuring the actual volume of air rushing by, it uses a piezoresistive element to calculate the exact pressure or vacuum inside the intake manifold. When you are sitting at idle with the throttle plate closed, manifold vacuum is extremely high and the pressure reading drops. The second you mash the gas pedal to the floor, that vacuum practically disappears, and the pressure inside the manifold shoots up to match the ambient atmospheric pressure outside. Your ECU takes this pressure data, combines it with engine RPM and incoming air temperature, and runs thermodynamic equations to figure out exactly how much fuel to squirt into the cylinders. But here is the trick that mechanics love to charge for. Half the time, the MAP sensor itself is completely fine. The real culprit is the tiny rubber vacuum hose connecting the sensor to the manifold. After a few summers of blistering underhood temperatures, these cheap little hoses get baked, turn brittle, and develop microscopic crack. Even the tiniest vacuum leak throws off the pressure reading, making the computer think the engine is under a much heavier load than it actually is. The ECU panics and dumps a massive amount of extra fuel. You will notice your MPG plummeting, you might see black soot spewing out of your exhaust pipe, and you will definitely pull rich mixture codes. Always inspect and replace that $3 vacuum line before you condemn a sensor. Now, speaking of temperature, let us talk about the intake air temperature sensor, the IAT. This sensor is either baked directly into your main airflow meter or threaded separately into the intake manifold, and its job is to act as the engine's weatherman. Air density changes drastically depending on the weather. Cold air on a freezing 0-degree Fahrenheit winter morning is packed tight with oxygen molecules, while hot air on a brutal 95-degree summer afternoon is thin and expanded. Your engine needs to know this exact temperature to dial in the air-fuel ratio. The problem happens when crankcase ventilation vapors sneak back into the intake and coat the IAT sensor bulb in a sticky film of oil. That oil acts like a thermal winter blanket. The sensor gets insulated from the actual incoming air and registers temperature shifts with a massive, lazy delay. In the dead of winter, this causes rough cold starts and stumbling because the engine thinks the air is warmer than it is. In the peak of summer, it can actually cause severe engine detonation and spark knock. If you plug in an OBD2 scanner and notice that the intake air temperature reading is wildly different from the actual outside weather, grab some pure isopropyl alcohol or dedicated electronic cleaner. A gentle spray removes that oily blanket and instantly restores your engine stability during seasonal weather shifts. Let us shift gears to the mechanical heartbeat of your engine, the camshaft position sensor, or CMP. This sensor works in lockstep with your crankshaft position sensor like two perfectly synchronized Swiss watches. While the crank sensor tracks overall engine RPM, the cam sensor reads a toothed wheel or a metal reluctor tab on the camshaft to tell the computer the exact position of the valves. It sends a unique reference signal on every rotation, flagging top dead center on cylinder number 1 so the computer can fire the spark plugs and pulse the sequential fuel injectors at the exact millisecond required. But when this sensor gets shrouded in sludge, degraded engine oil, or develops internal heat cracks, that precise reference signal drops out. When the ECU loses track of camshaft timing, it instantly goes into self-preservation limp mode. It abandons sequential fuel injection and falls back to batch fire, spraying fuel into all cylinders simultaneously just to keep the engine turning over. Your idle becomes lumpy, cold cranking takes agonizingly long, and you might experience mysterious hesitations right around 2,500 revolutions per minute. People often waste hundreds of dollars swapping out ignition coils or spark plugs trying to chase down these stutters, completely unaware that a failing magnetic cam sensor is scrambling the firing order. Pulling the sensor out and wiping off the metallic sludge from the magnetic tip can literally work miracles. Right next to that airflow system sits the throttle position sensor, the TPS, which on modern drive-by-wire cars is sealed right into the side of the electronic throttle body. Every time you are stuck in brutal stop-and-go city traffic, hot exhaust gases and oil vapors bake onto the backside of the throttle plate, creating a thick, sticky ring of black carbon buildup. This nasty crust physically prevents the butterfly valve from closing all the way or opening smoothly. From the driver's seat, this feels like a dead spot when you step on the gas, a sluggish response when pulling away from a stoplight, or a weird bucking sensation when you have cruise control engaged on the highway. If you unbolt the intake boot on any high-mileage daily driver, you will see that ugly black carbon ring staring right back at you. Cleaning it out with some throttle body solvent is easy, but here is the insider tip. After you clean it, you must perform an electronic throttle relearn procedure. By turning the ignition key through a specific sequence or using a scan tool, you teach the computer where the new, clean idle stops are. This simple calibration resets your shift points and makes your throttle response feel razor sharp, just like the day the car rolled off the dealership lot. Now we arrive at the absolute king of fuel trim headaches, the mass airflow sensor, the MAF. This little unit sits right behind your air filter box and uses a microscopic heated metal wire to measure the exact mass of air entering the engine. But when that delicate wire gets coated in microscopic road dust and oily crankcase fumes, its ability to measure heat transfer is completely crippled. Here is the wildest part about a dirty MAF. Your car might start fine, your fluid levels are topped off, your spark plugs are brand new, yet at a stoplight, your engine shivers like a wet dog. You feel the vibration in the steering wheel and through the floorboards. But the moment you hit the gas and accelerate, the shaking magically vanishes. Why? Because at idle, air trickles past the sensor very slowly. A tiny layer of dirt severely distorts that low flow reading, making the ECU guess the fuel delivery. It oscillates back and forth, running rich 1 second and lean the next. When you accelerate and RPMs climb, a massive torrent of air rushes over the wire, making the dirt's margin of error negligible so the engine smooths out. But before I tell you the exact warning codes to look out for and how to fix this without destroying the sensor, make sure you hit that subscribe button right now. We are building an incredible community of drivers who actually understand their machines, and you do not want to miss our upcoming maintenance guides. Let us talk about what happens when that MAF sensor finally starts dying, because the check engine light is the most misunderstood warning on your dashboard. When your MAF acts up, you will trigger codes ranging from P100 to P104. P100 is a general circuit malfunction. P101 means the sensor's output is completely out of the expected performance range. P102 indicates a low voltage input, meaning the sensor is telling the ECU there is way less air coming in than there actually is. P103 is high voltage, signaling an impossibly high volume of air. And P104 is the sneaky intermittent code that comes and goes, tricking you into thinking the problem fixed itself. Here is the expensive secret mechanics know. The computer does not throw a check engine light the very first time it sees a bad MAF reading. The ECU runs continuous readiness monitors, comparing the airflow data against its pre-programmed fuel maps over multiple drive cycles before it finally decides to illuminate that dashboard light. By the time your check engine light actually turns on for a P101, your vehicle has already been suffering from poor fuel economy and degraded performance for weeks. The light is not an early warning, it is a late confirmation. Drivers see that code, panic, and pay a shop to clean the throttle body, swap air filters, and smoke test the intake, wasting solid cash when the MAF wire was the primary failure all along. To make matters worse, an uncalibrated airflow system directly abuses your fuel rail pressure sensor. This sensor sits mounted to the high-pressure fuel rail and constantly monitors the exact PSI of the fuel being pushed to the injectors. When incoming air calculations are scrambled by a bad MAF or MAP sensor, the ECU commands the fuel rail to compensate. If the pressure sensor itself fails or gets fed bad baseline data, your injectors either starve the engine or flood it. Starvation causes violent misfires, hesitation under wide open throttle, and hard starting. Flooding washes the protective oil film off your cylinder walls and dumps unburned raw fuel straight into your catalytic converter, practically melting its internal honeycomb structure. Long term, running with erratic fuel pressure burns out your fuel pump and destroys your injector, turning a minor annoyance into a catastrophic repair bill. If you need to service this sensor, always disconnect the negative battery terminal first and relieve the system pressure. You unplug the electrical harness, carefully thread the sensor out of the rail, and blast the sensor tip and harness pins with dedicated electrical contact cleaner. Letting it air dry completely before rethreading it can save you from buying a brand new replacement part that usually retails anywhere from $250 to $650 at the parts counter. A $10 can of spray versus a $600 parts bill is the easiest math you will ever do in the garage. Now, let us bring in a crucial component that works behind the scenes to keep this entire air and fuel ecosystem alive: the oxygen sensor, specifically the upstream O2 sensor sitting right off your exhaust manifold. While the MAF and MAP sensors guess how much fuel the engine needs based on incoming air, the oxygen sensor acts as the ultimate quality control inspector. It sniffs the exhaust gases rushing out of the combustion chamber to see how much unburned oxygen is left over. If it sees too much oxygen, it tells the computer the engine is running lean. If it sees virtually zero oxygen, it screams that the engine is running rich. This creates what engineers call closed-loop fuel control. But here is where the domino effect crushes your wallet. When your MAF sensor is dirty and constantly underreporting airflow, the ECU trims back the fuel. The engine runs lean, combustion temperatures skyrocket, and the oxygen sensor gets baked by superheated exhaust gas. Eventually, the O2 sensor gets sluggish and stops switching back and forth between rich and lean readings. Now your engine computer is effectively blind at the intake and blind at the exhaust. It defaults to a rich safety map, dumping fuel into the cylinders just to keep the valves from burning up. You will watch your fuel economy drop from a respectable 25 mpg down to a pathetic 14 mpg overnight. You are literally spraying dollar bills out of your tailpipe just because two tiny sensors are covered in soot. Let us add one more piece to this diagnostic puzzle that frequently gets misdiagnosed as an airflow issue: the NOx sensor. Threaded directly into the engine block or bolted into the valley under the intake manifold, this sensor is essentially a piezoelectric microphone, listening for the distinct, high-frequency pinging sound of engine detonation. When pre-ignition or spark knock occurs, usually caused by cheap low-octane gas, carbon buildup in the combustion chamber, or a faulty intake air temperature sensor advancing the timing too far, the NOx sensor hears the ping before human ears can. Instantly, it signals the ECU to retard the ignition timing to save the pistons from shattering. But these sensors live in the harshest environment imaginable, constantly subjected to extreme engine heat and road moisture. Over time, the internal crystals degrade or the wiring harness gets chewed up by engine heat. When a NOx sensor fails, it either reports false knocking, causing the computer to permanently pull timing and robbing your engine of 30 horsepower, or it goes completely deaf, allowing severe pre-ignition to hammer your rod bearings into dust. If your car feels unusually sluggish when pulling up a steep grade or merging onto the interstate, do not just blame the transmission. A phantom NOx sensor signal might be pulling your ignition timing into the dirt. So, how do we fix the root cause of the airflow problem without breaking the bank? You are going to clean that mass airflow sensor yourself. First, pop the hood and locate the sensor tube right next to your air filter housing. Unclip the electrical connector and remove the two small screws holding the sensor inside the intake tube. Carefully pull the sensor out, making sure you do not bump the delicate sampling tube against the plastic housing. Now, listen to me very carefully. You must only use dedicated MAF sensor cleaner spray. Never use brake parts cleaner, carburetor cleaner, or soapy water. Those aggressive, harsh chemicals will instantly melt the fragile protective coating on the hot wire and ruin the sensor forever, turning a free free DIY fix into a $300 trip to the auto parts store. Hold the sensor over a shop towel and generously blast the platinum wire and the tiny resistors inside the plastic cage. Do not touch the wire with your fingers, a cotton swab, or a rag. Let the chemical spray do all the heavy lifting. Once it is thoroughly flushed out, set the sensor on a clean surface and let it air dry completely for about 15 minutes. The alcohol-based formula evaporates rapidly without leaving any chemical residue behind. Once it is bone dry, reinstall the sensor into the intake tube, tighten down the screws, and plug the harness back in. Start the engine up and let it idle. You will immediately feel the engine smooth out, the steering wheel vibrations will vanish, and your fuel trim numbers will stabilize. That is the beauty of understanding how these electronic systems communicate. You do not need a mechanical engineering degree or a shop full of expensive diagnostic carts to keep your ride running in peak condition. You just need to know how sensors talk to each other, how to read the subtle symptoms your car gives you, and how to perform basic precision maintenance. Drop a comment down below and tell me what vehicle you are driving, what your current MPG is looking like, or what weird OBD2 trouble codes you have been fighting lately. I read through the comments and love helping you guys troubleshoot your builds. If this deep dive saved you from throwing expensive parts at a simple dirty sensor, hit that subscribe button, smash the like button, and share this with a buddy who is constantly complaining about their gas mileage. Until next time, keep your tools clean, keep your tire pressure set, and I will see you in the next garage session.